dimensional analysis. Based on dimensional analysis, 2 to 3 questions compulsory in NEET and JEE mains. Other state level competitive examination compulsory questions. Okay, today we'll discuss dimensional analysis by very easy methods. So with simple tips, okay, we can learn the dimensional analysis. Okay, based on the dimensional analysis problems also we'll solve in this class. Okay, dimensional analysis. Okay, so we know that fundamental physical quantities. What are fundamental physical quantities? In SI system there are 7 fundamental physical quantities. The first one length, second mass, third one time, fourth one electric current, fifth one thermodynamic temperature, sixth one luminous intensity, and seventh one amount of substance. Their dimensional formulas. We have to know that fundamental physical quantities dimensional formulas. Then we can derive the other derived physical quantity dimensional formulas. Let's see. Serial number fundamental physical quantity, fundamental physical quantity dimensional formula. Okay, and the fundamental physical quantity unit. Okay, now first one length. Length dimension formula is what? L. This is only single letter L, so we can't say this one formula. So how to write formula? In terms of 3 physical quantities we have to write MLT. Here M is not there, so that's why M power 0 I am writing. Here L is there, L power nothing means how much? 1, and T not there here, T power 0 I am taking. After writing this formula I am closing with square brackets. Here unit, length unit in SI, length unit is what? Meter. Like that only mass dimension formula is what? Capital M. I am writing in terms of 3 physical quantities. Okay, length, mass, time. Here mass is there, so mass power 1 I am taking, length not there, L power 0 I am taking, and time also not there, T power 0 I am taking. Okay, length, mass, SI unit is what? Kilogram. So like that only third one time. Time dimension formula is what? T. Or in terms of 3 physical quantities, every dimension formula we have to write in terms of minimum 3 physical quantities. Okay, length, mass, time. Here mass not there, M power of 0 I am taking, length also not there, L power of 0, T is there, nothing means how much? Power 1. Okay, time unit is what? Second. So like that only electric current. So electric current dimension formula we can denote with letter I or A. Letter I or A. So I am taking okay, R. So every dimension formula we have to represent with 3 physical quantities: mass, length, time. Here mass not there, length also not there, time also not there. So that's why I am taking powers 0, 0, 0. Then fourth one current. Current dimension formula is what? I am taking I power of 1. So current unit is what? SI unit is what? Ampere A. Next, fifth one, okay, thermodynamic temperature. This one also same, we can denote with letters K or theta, Kelvin or theta. So I am taking K, I am taking R. Okay, here also mass not there, M power of 0, L not there, L power of 0, T also not there, T power of 0. Then K I am taking, I am closing the bracket. Okay, temperature unit is what? SI unit is what? Kelvin. Okay, fine. So here k power nothing means what? Power 1. Okay. So next one, sixth one, luminous intensity. Luminous intensity. Luminous intensity. The unit is what? Candela. So here I am taking the dimension formula luminous intensity. CD I am taking, or here mass, length, time not there. So that's why I am taking power zeros. Then CD I am taking. So symbol what? Unit is what? Candela. Power nothing means what? 1. Last one, amount of substance. Last one is what? Amount of substance. Amount of substance. Dimension formula is what? Mole. Or we can write M0, L0, T0 and mole. MOL, mole. Power 1 we can take. Okay. Unit is what? MOL, mole. Okay. So if we observe, all dimension formulas will represent with capital letters only. The last two, luminous intensity and amount of substance, we are denoting with the small letters. So the rest all dimension formulas we are representing with capital letters only. Dimension formulas, 95% dimension formulas we have to represent in capital letters only. So these are the 7 fundamental physical quantities. Based on these 7 fundamental physical quantities, we can write the other derived physical quantities. Other derived physical quantity dimension formulas. Okay. So now I am explaining other derived physical quantity dimensional formulas. Okay. Now we'll discuss the derived physical quantities. Okay. Here serial number, derived physical quantity, derived physical quantity. For derived physical quantity purpose, okay, if you remember the expression, easily we can derive the formula. Expression, then dimensional formula. Okay, finally the dimensional formula, unit also will write. Okay, here nearly 50 dimensional formulas are there, derived physical quantities. So very easy method will discuss that 50 dimensional formulas now. Okay, here first one, for example, area. Area expression we know that, for example, so rectangular slab is there. So area is what? How will measure? Length into breadth. Okay, length into breadth. Here length, how will use? Dimension formula is what? L. So breadth also by using scale only will measure. So that is also nothing but length only. So L. L into L. So here L power of 1 is there. Here also L power of 1 is there. Here bases are equal. Power should be added. L power 1 plus 1, 2. L square is the area dimensional formula. So total formula type I am writing. So generally just now we learn, okay, dimension formula will represent in terms of 3 physical quantities: mass, length and time. Okay, I am writing mass here. Mass is not there, power 0. Length power is there, power 2, and time power 0. Time is not there, power 0 I am taking. Okay, so here unit, length unit is what? Meter. Power how much is there? 2. As it is I am writing. So that is meter square is the unit of area. Here observe, here these powers are called like 0, 2 and 0. These powers are called dimensions. These powers are called what? Dimensions. That meaning here mass dimension is how much? 0. Length dimension is how much? 2. Time dimension is how much? 0. In examination they can ask like this: what is the dimension of time? Okay, in area formula. So time dimension is how much? 0. So if they ask length dimension is how much in area, so that is 2. Okay, so these are called dimensions. Okay, so next, volume. So volume expression, we know that length into breadth into height. Length into breadth into height. Length dimension formula is what? L. Breadth is what? L. The height also, that is also L only. L into L into L. Bases are equals. Power should be added. 1 plus 1 plus 1. Total how much? 3. L power of 3. L cube is the dimensional formula of volume. In terms of three physical quantities, I am writing m power of 0, L power of 3, T power of 0. Okay, unit. Here, length unit is what? Meter. Power how much is there? Okay, power how much is there? 3. Meter cube is the unit of what? Volume. So next one, density. Density. We know that expression of density, mass by volume. Density expression is what? Mass by volume. Mass dimension formula is what? Capital M. And volume dimension formula is what? Just now we learned L cube. Okay, M. And this power denominator, this power I am sending to numerator. Why? Because in dimension analysis, all formulas we have to write in numerators only, not in denominators. So that is why this denominator term L cube I am sending to numerator. So what happens that time? This positive 3 becomes negative. Okay, M L power of minus 3. Okay, here dimensional formula we can show that in terms of three physical quantities. Okay, so otherwise we can show that like this also in terms of two physical quantities also. And unit I am writing. Expression is what? Mass by volume. Mass unit is what? Kilogram per. Volume unit is what? Meter cube. Kg per meter cube is the unit of density. Okay. Next one. Fourth one. I am taking speed. Speed. Distance by time. Speed is what? Speed expression is what? Distance by time. Okay, distance dimension formula is what? Nothing but length L, and time dimension formula is what? T. Okay, I am sending to this T power, nothing means what? 1. I am sending to numerator, so what happens that time? Power minus 1. L T to the power of minus 1 is the velocity or speed dimensional formula. Velocity also same only, speed or velocity. Velocity also same only. Velocity purpose what will take? Displacement by time will take. Velocity purpose what will take? Displacement by time. So velocity or speed both are having same dimensional formulas. So that is LT to the power of minus 1. Unit. Length unit is what? Meter. Time unit is what? Second. So that's why meter per second. Meter per second is the dimensional formula of velocity or speed. Next, acceleration. Acceleration. So that is acceleration definition. We know that the rate of change of velocity is called acceleration. Okay. So according to that, I am writing change in velocity. Change in velocity by time, or simply velocity by time also you can remember. The velocity dimension formula just now we learned LT to the power of minus 1 divided by time dimension formula is what? T. So this T I am sending to numerator, denominator T I am sending to numerator. Just now we discussed here nothing means what? Power 1. This T power of 1 I am sending to numerator, T to the power of minus 1. Here that equal to L T to the power of, bases are equal, power should be added, minus 1 plus of minus 1, total how much? Minus 2. Unit. Here length unit is what? Meter. Time unit is what? Second. Power how much is there? Minus 2. As it is minus 2. Now force. Force expression, we know that mass into acceleration. So how to remember? By well-known formula is there. F equal to ma formula is there. Okay, just you remember the F equal to ma. Okay, then mass into acceleration expression is what? Mass into acceleration. Mass dimension formula is what? Capital M. And acceleration dimension formula is what? Mass into acceleration is what? Lt to the power of minus 2. Total how much? M L t to the power of minus 2. M L t to the power of minus 2 is the dimensional formula of force unit. According to the dimensional formula, unit is what? Mass unit is kilogram. Length is what? Meter. Time is how much? Second, power minus 2. Or according to the scientist name, the unit is what? Newton. Okay, Newton symbol is what? N. Okay, so next, work or energy also we can take. Work or energy. Okay, work is nothing but energy. Work formula, we know that W equal to Fs. Just you remember the work formula, W equal to Fs. Force into displacement. Force into displacement. Force dimension formula is what? MLT to the power of minus 2. And displacement dimension formula is what? L. Total how much? M. Here L is there, here also L is there. Bases are equal, power should be added. Okay. L power 2 t to the power of minus 2. Okay. Unit according to this unit is what? Kg meter square and second power minus 2. Kg meter square second power minus 2, or according to the scientist name, the SI unit of work or energy is what? Joule. Okay. So next, eighth one, power. Power definition, we know that rate of doing work is called power. Power formula also we remember, work by time. Okay, expression is what? Work by time. Work dimension formula is what? M L square t to the power of minus 2 by time is what? T. So this denominator t I am sending to numerator. What happened? Become minus 1. Already here minus 2 is there. Okay. So minus 2 is there. Here minus 1. Total how much? Bases are equal. Powers I am adding. Minus 2 plus of minus 1. Total minus 3. That equal to ml square t to the power of minus 3. According to this unit is what? Kg meter square second power minus 3. So but according to, okay, scientist name I am writing the formula watt. Scientist name watt I am writing. Okay. So next one, ninth one. Okay. Pressure. Pressure. So pressure expression is what? Force by area. Pressure definition, we know that force acting per unit area. Okay, pressure P equal to F by A, force acting per unit area. Force by area. Okay, I am writing force dimension formula. What is the force dimension formula? MLT to the power of minus 2 divided by area dimension formula is what? L square. Here numerator 1 L and denominator 1 L cancel. In denominator one more L is there. I am sending to numerator. It becomes power minus 1. This denominator L I am sending to numerator. It becomes minus 1. This t power of minus 2 as it is. Okay. Pressure unit according to the definition. Force by area. Force unit is what? Newton. Area unit is what? Meter square. Newton per meter square. Newton per meter square, or according to the scientist name Pascal. According to scientist name Pascal. Okay, we can write. So 10th one. Okay. So I am writing momentum. Momentum. Momentum, you know that momentum is the product of mass into velocity. Okay. So P equal to what? mv, mass into velocity. Mass into velocity. Mass dimension formula is what? M, and velocity dimension formula is what? Lt to the power of minus 1. Total how much? ml t to the power of minus 1. Okay. Here unit unit is what? Mass unit is kilogram, length unit is meter, second power minus 1. So just now we discussed the 10 dimensional formulas. Okay, so what is the use of this dimensional formula? Okay, so just example I'll give formula how they'll ask in examination. Okay, just I'll discuss one problem. Okay, if one question I'm giving, the dimension of ratio of force into distance by power r is dash. They're asking. Okay, just now we learned dimensional formulas. Okay, so few dimensional formulas we learned. Based on that, how they'll ask questions I'm giving. Okay, sample question 1 I'm giving. Force into distance by power is dash. So they given options like length, mass, time and electric current. Okay, we'll see which option is correct. Force dimensional formula is what? ml t to the power of minus 2, and distance is what? L, and power is what? ml square t to the power of minus 3. Any cancel numerator and denominator? Yes. Here m cancel. Okay, here L into L square, here L square cancel. T power of minus 2, here minus 3 is there, minus 2 cancel, minus 1 is there. This t power of minus 1 I am sending to numerator. What happened? T to the power of plus 1. This minus 1 sending to numerator, t to the power of plus 1. So that meaning is what? T power of 1 only. So that is time. 4 options are given: length, mass, time and electric current. Which option is correct? Time. Okay, so like that only. One more question I am giving. Okay, if x square by mass is equal to kinetic energy, then x is what? Then x is what? X is what? X is what? They are asking question. Okay, we'll substitute the dimensional formulas both the sides. X square by mass dimension formula is what? Capital M. Kinetic energy, so is nothing but energy dimension formula is what? ml square t to the power of minus 2. Okay, x square by, okay, x square is equal to this m I am sending to. Okay, so this side m into m is what? M square L square t to the power of minus 2. Here x square is equal to, here square I am taking common, ml t to the power of minus 1 whole square. So this power 2 is there. I am taking whole power. Okay, so what happened? Both the sides I am cancelling the powers. Therefore x equal to what? ml t to the power of minus 1. Sometimes they will give options directly like ml t to the power of minus 1 or ml minus 1 t power of 1. Okay, different options they'll give. Sometimes they'll give this physical quantity name also. Actually this physical quantity name is what? Momentum. Mass to velocity. Momentum. So momentum is the correct answer. Okay, so here just a sample purpose I shown these two problems. So later in the